All right, so we're talking about when a straight line and a parabola intersect. So I'm looking at what's the ordered pair where they hit. And we're going to do one, like example 1. I'm actually going to do the math, like the algebra myself, and draw the graphs. But on example 2 and 3, we get to go on Desmos, so I'll transfer the screen to that. But first, we need to talk about solutions, like the possibilities. So if I had, let's do like green and red. How about green and I guess green and blue. It might bleed through. We'll see. Okay. So let's do linear. A straight line could be like this. Okay. And then I'd have a parabola, maybe like this. How many points of intersection will that have? Think careful. Two. My green line is going to go further. It's going to intersect. So this is going to be 2 solutions. I know. Okay. Here's going to be 1 solution. These are tricky to draw, but let's say my parabola looks like that. And then my straight line is going to be barely touching it, just in 1 point. That would be 1 solution. They only hit once. How many times do they intersect? Twice? Once? None. Here's none. My parabola could be upside down. And I could have, what about like a horizontal line? Totally doable, but they're never going to touch. So that would be no solution. Okay? All right. No solution. So the first one, I'm actually going to have us do the substitution method, and then we're going to graph them. So substitution method means that I am, if they're both y equals, what do you think a good possibility would be? If they're both y equals.
Parabolas.
One of them is a parabola, one of them is a straight line. How would I solve using substitution? If they're both y equals.
Factor.
I'm going to substitute. I'm going to replace something with something, but they're both y equals. You saying something? Say it louder. Oh. Okay. If these y's are the same, what do I know about these? They could be the same. So you're going to set, because they're both y equals, I'm going to set these 2 equal to each other. Then I have to, I can't do anything with that. So you're going to move everything over to one side to set it equal to 0, because maybe I can factor it. So I'm going to move everything to one side. X squared minus 2x equals 0. And then what? How can I factor this? I can. How? Can I do the x?
Yeah.
No, there's not 3 things. You're looking at this, and I'm trying to ask you how to factor it.
Oh, you could just take out an x.
Yes, that's called GCF. What's my leftovers in parentheses? X minus 2. Set each one equal to 0, as always. Whenever I have an equal 0, set it equal to 0. And isn't that going to be positive 2? So now I have the beginning of my location of the ordered pairs. 0 is my x. I don't know my y yet. And then 2 is my x. I don't know my y yet. So I'm finding the ordered pairs where they're going to hit. So if x equals 0, what's y going to be? Because I have two equations to choose from. Which equation do you want to plug it into? Bottom one. Y equals 2 times 0. So what does y equal? 0. So there I just found if x equals 0, plug it back into my original. Y equals 0. Good. If x equals 2, then what? You want to do the top one? Plug in. Because I have these two equations to choose from. Y equals 2 times 2. 2 times x. 2 times 2. Y equals 4. So there is the location that they are going to intersect. I'll mark it now. And then 2 comma 4. But now I'm going to graph them. So how do I graph a y equals x squared? The basic, that's my parent function, you guys. How do I graph y equals x squared?
Parabola.
You've probably done it so many times. It's a parabola. Where do I start? How do I move it? Where? Start at 0, 0. And then what's my slope of y equals x squared? Up 1, right 1. What do I do the next movement? Remember, I'd be like up 1 over 1. Over 2 up 4. Yay, you're best. Okay. Draw the parabola. Okay. How do I graph the second one? Y equals 2x. This is a straight line. Linear. I do not go to 2 and draw a straight line. That would be like if it said y equals 2. That would be a straight line. Y equals 2x, mx plus b. Y equals 2x.
Start at the 0.
Yeah, start at 0. 2x plus 0.
Let's just do it up.
Rise 2, run 1.
Yeah.
Rise 2, run 1. Reverse it. Down 2, left 1.
Two solutions.
Okay. Isn't that where they hit? The line hits the parabola in 2 spots. I found it using math where I had to solve for x and then plug it in to find y, and then I drew pictures. So the next thing I want to have us do is example 2 and 3. We're not going to do substitution method because the equations would be too, let's see. So let's go to Desmos. So you guys can go to Desmos too. You need to make 3x squared, 3x, wait, what is that? Where's the math thing? Down here. 3x squared, okay. And then 3x minus 2. Woo! Okay, where are those going to graph? Sketch those on your paper, please. Transfer them to paper. What? No. This example 2. Mine says 3x minus 2. Okay, check this out. I'm changing the screen for you. This is what my 2 look like. Can you type that in, please? Oh, you can't see it. Sorry, it says 3x squared, and then it says. Okay, graph those on your paper. Draw the lines, please. And then figure out where they're going to intersect. Okay, so where do they intersect, you guys?
They don't.
They don't intersect. No solution. So I'm going back to my paper. No solution. Okay. Now let's do example 3. Please plug those two equations in. Go ahead. And where do those intersect? Three x squared plus 3x minus 5. And you can write it. You guys need to change this 2x minus y to y equals mx plus b. You cannot type 2x minus y into Desmos. You have to change it to y equals mx plus b. Notice we've never typed in y equals on any of these. So change it to y equals mx plus b. What'd you get? If I subtract 2x, and then I have to divide by -1 because it needs to be positive y equals mx plus b. You've got to be able to change these on your own. 2x minus 3. Ooh! They hit, so hover over. One spot they hit is 0.6, comma, -1.6. And the second spot they hit is -1, -5. Okay. So sometimes they don't hit, sometimes they hit twice. Just depends. Okay. Most of our practice together is going to be the backside. Looking at a graph and writing down where they hit. Maybe I better get a new paper because the blue. Okay. All right, where do they hit? Just make an approximation, guys. It's going to be fractional or decimals. Okay? But you just got to zoom in on your eyes. Where does it hit? 1 comma, up 1 box, 1 point. You want to do 1.5? I'm okay with that. It's just approximate. And right here, way down here they hit. That's going to be 1, 2, 3, 4, 5 and a half over, down 1, 2, 3, 4, 5, 6, 7 and a half. I'm just approximating. But if I don't have the equation, so I can't even put those into Desmos, you know? But you're just visually looking. Where do they intersect? And approximating is fine. All right, do the last one. Those actually hit perfect. Yay, they hit perfect. So what is that order pair going to be? Over 2 up, yep. Over 2 up 5, and what else?
6, 5.
Okay.
My height.
Okay, so I'm looking, where do they intersect? I'm going to do delta math today where you're going to get graphs and you have to write in where do they intersect. It's an ordered pair answer. It's called the solution, right? Solution, ordered pair answer. Okay, solution. All right, so I'll stop recording.